Hello friends, welcome to engineering tutorial. So we'll continue our discussion with the application of Thevenin theorem, and this is the fifth question. Okay, fifth question that we are going to solve using Thevenin's theorem. So in this question we have the circuit as given, and we have to find out the voltage across this 5 ohm resistor with the polarity assigned. So we will be using Thevenin's theorem. So the two important things which are important when we apply Thevenin's theorem are Thevenin voltage and Thevenin resistance. Okay, so we have to find both VTH and RTH. So as we are using Thevenin's theorem and we have to find out the voltage drop across this 5 ohm resistor, so in order to determine the equivalent circuit we have to draw the circuit excluding that resistor. Okay, let us redraw it. 12 volt, 6 ohm, 3 ohm, 2 ampere, 4 ohm, 12 ohm, and 19 volt. Now as we have open circuited it, we have to find the Thevenin voltage. Thevenin voltage between these 2 points. Okay, so we'll be using nodal analysis here. Okay, let us use nodal analysis and assign pole voltages V1 and V2 at these 2 nodes. VTH is simply V1 minus V2. VTH is V1 minus V2. So you have to find V1 and V2 using nodal analysis. Let us assign the currents. This is one current, this is one current. Here this is, let's say, one current, this is one current. Here it is 2 ampere, it is outgoing 2 ampere. Okay, so first let us put nodal analysis at V1. So 12 minus V1 by 6 plus 2 incoming currents and 1 outgoing current, V1 by 3. That implies 2 minus V1 by 6 plus 2 is equal to V1 by 3. That implies 4 is equal to V1 by 3 plus V1 by 6, which is equal to, let's say, 2 V1 plus V1. That implies 3 V1 is equal to 6 into 4, which is 24. Or that implies V1 is equal to 24 by 3, which is equal to 8 volt. So V1 is equal to 8 volt. We have determined V1 is equal to 8 volt. Now let us determine V2 using the same nodal analysis technique. Applying nodal analysis at this node. Okay, so incoming currents are only 19 minus V2 by 4, and outgoing currents are this and this 2 ampere. Okay, so here the nodal analysis equation will be the two outgoing currents, 2 plus V2 by 12 equals to 19 minus V2 by 4. That implies 2 minus 19 by 4, we have taken 19 by 4 on this side, equals to minus V2 by 12 minus V2 by 4. So this is 2 minus 19 by 4 is my 8 minus 19 by 4 equals to, here the LCM is 12 minus V2 minus 3 V2, which is equal to 4 V2 by 12. That implies, let us take it here, okay, it is minus 11 by 4. So minus 11 by 4, 8 minus 19 by 4 is minus 11 by 4 is equal to minus 4 V2 by 12. That implies V2 is 11 into 12 by 16, or 4 into 4, 12, 3, which is 33 by 4. V2 is 33 by 4 volt. Okay. So we have got both V1 and V2. Now we have to determine VTH. So these are basic mathematical calculations, you can all do that. Just you have to be careful about the current directions which you have assigned. All the incoming currents or the currents that are going towards the node on one side, all the outgoing currents on the other side. That is the only thing that you have to take care of. Rest are just basic mathematical calculations. So now VTH is V1 minus V2, which is equal to 8 minus 33 by 4. It is equal to 32 minus 33, which is equal to minus 1 by 4 volts. Sorry. VTH is minus 1 by 4 volt. So here the negative sign means that the polarity which we assumed for VTH, it is the opposite of that. It is actually in this way, minus plus. But does not mean that it is wrong. The answer is not wrong. It's just that the polarity which we assumed, plus minus, it is the opposite of that. Okay, so we have calculated VTH. Now let us calculate RTH. So RTH can also be easily calculated across these 2 points. For that, what we have to do is we have to deactivate the voltage sources and current sources, the independent voltage and current sources. So the independent voltage sources should be replaced by short circuits. We have all done that in the previous questions also. They are replaced by short circuits. Current sources are replaced by open circuits. Okay, so the RTH here between these 2 points will simply be, here in between these 2 points 3 and 6 are in parallel, 4 and 12 are in parallel, then they get added up. So RTH here is 6 parallel 3 plus 4 parallel 12. Okay, 6 parallel 3 plus 4 parallel 12, which is 6 into 3 by 6 plus 3, which is 9, and here 4 into 12 by 4 plus 12, which is 16. Okay, it is plus, sorry, plus. So it is 2, 3, 6, 9, 2 plus 4, 3. Okay, 4, 16, 3, this is 3, 6, 9, 3, this is 2. Okay, 2 plus 3, which is 5 ohm. RTH is 5 ohm. So we have got both VTH as minus 1 by 4 volt, RTH as 5 ohm. Now our objective is to determine the voltage drop across this 5 ohm resistor. Okay, so let us do that. So for this we have to draw the Thevenin equivalent circuit and then include the 5 ohm resistor with it. Okay, so we determined the Thevenin equivalent circuit across this 5 ohm terminal. So we got VTH as minus 1 by 4 volt, RTH as 5 ohm. Then we will include the 5 ohm resistor across which we have to determine the voltage drop. So we can apply a simple voltage division rule here. V0 is minus 1 by 4, this is 5 ohm, okay, into 5 by 5 plus 5, which is simply 2 here, and it will be minus 1 by 8 volt, minus 1 by 8 volt, which is minus 0.125 volt, I think, yes, 0.125, yes, and we can also write it as minus 125 millivolts. Anything, this is also correct, right? This one is also correct. So V0 is minus 1 by 8 volts. So here the minus sign means the polarity here is assigned in this way, plus minus. So with respect to this polarity which is assigned in the question, see, there is a reason why the polarity has been assigned in the question. As per this polarity which is assigned in the question, the voltage drop is minus 1 by 8 volt. But if the polarity would have been assigned like this, plus minus, okay, then it would have been plus minus like this, and the answer would have been plus 1 by 8 volt, opposite. So the answer is correct. It's just as per the polarity which is assigned, the plus and minus sign, they come into play. So here, as per the polarity which is given in the question, the answer is minus 1 by 8 volt. Easier. So this is the 5th question that we have solved using Thevenin's theorem. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.